Today we are going to discuss about animal kingdom. All the animals belongs to the kingdom Animalia. Animal kingdom includes levels of organization. Levels of organization. There are three types of levels of organization. Cellular level of organization, cellular level, tissue level, cellular level, tissue level, and organ level. And then organ system level of organization. Organ and organ system level. Organ and organ system level of organization. Cellular level of organization, in which single cell perform all the functions. In cellular level of organisms, cells, different types of cells. Different types of cells perform their functions. Before that, another one is protoplasmic level of organization. Protoplasmic level. In protoplasmic level, single cell perform all the functions. That is protoplasmic level. In cellular level, different types of cells perform their functions. In cellular level of organization, different types of cells perform their functions. In protoplasmic level, single cell perform all the functions. Example, protozoans. In cellular level of organization, different types of cells which perform their functions. Example, porifera. What type of level of organization in porifera? Cellular level of organization. The next one is tissue level of organization. In tissue level of organization, cells aggregate to form the tissue. These tissues perform their functions. That means different types of tissues which perform different functions. Tissue level of organization is exhibited by example, Cnidaria and Ctenophora. Cnidaria and Ctenophora. And next one is organ level of organization. In organ level of organization, tissues aggregate to form the organs. In organ level of organization, various organs perform their functions. For example, lungs for respiration, heart for circulation, etc. And last one is example for organ level of organization, platyhelminthes. And last one is organ system level of organization. It is the highest level of organization in which various systems perform their functions. Various organ systems perform their functions. Example for organ system level of organization is platyhelminthes to chordata. That means for platyhelminthes exhibit both organ system and organ system level of organization. Platyhelminthes exhibit organ level and organ system level of organization. Once again, I repeat, there are different types of levels of organization. There are three major types: cellular level, tissue level, organ level, and organ system level. Protoplasmic level, example, protozoa. Cellular level of organization, porifera. Tissue level of organization, Cnidaria and Ctenophora. Organ level Example, platyhelminthes, organ system level, platyhelminthes to chordata. Here, lowest level of organization, important, lowest level of organization is cellular level of organization. Highest level of organization, organ system level of organization. Very, very important. Lowest level of organization, cellular level. Highest level of organization. Lowest level of organization in the kingdom Animalia. Lowest level of organization, kingdom Animalia or metazoa is cellular level. Cellular level. Next, lowest level of organization in eumetazoa. Eumetazoa is tissue level. Tissue level. Once again, lowest level of organization in metazoa, cellular level. Eumetazoa, tissue level. Highest level of organization is organ system level of organization. That is about levels of classification. Then coming to symmetry and coelom. Symmetry. What is symmetry? What is symmetry? The arrangement of body parts in a geometrical design is called symmetry. Arrangement of body parts in a geometrical design is called symmetry. What is symmetry? Arrangement of body parts in a geometrical design is called symmetry. Symmetrical animal, any symmetrical animal can be cut into equal parts. If the organism does not give equal part, those organisms does not exhibit symmetry. Those animals are called asymmetrical animals. Asymmetrical animals. There are different types of symmetries. They are asymmetry, radial symmetry. Type of radial symmetry is biradial symmetry. Another type of radial symmetry is pentamerous radial symmetry. Asymmetry, radial symmetry, biradial symmetry, pentamerous radial symmetry. Last one is bilateral symmetry. In asymmetrical animals can be cut if it does not give two equal parts. In general, shapeless animals exhibit asymmetry. Example, amoeba. And most of the puriferans and adult gastropodons exhibit symmetry. Radial symmetry. In radial symmetry, the principal axis is oroeboral axis. This is the oral end and this one is aboral end. This is oroeboral axis. For example, this one is hydra. What are the tentacle organs? What are the locomotor organs in hydra? Tentacles present around the oral or mouth. This principal axis is in radial symmetry is oroeboral axis. That means these animals can be cut through the oroeboral axis. It gives two equal parts. The number of planes in oroeboral, many. Number of principal axis 1. Number of planes many. That means through oroeboral axis it gives different. When we cut through the oroeboral axis, it gives two equal parts. What type of organisms exhibit radial symmetry? Radial symmetry is exhibited by example, cnidarians. Cnidarians. In general, Cnidarians and ctenophorans. Cnidarians and ctenophorans exhibit radial symmetry. Coming to biradial symmetry is a type of radial symmetry. So what is the principal axis in biradial symmetry? In biradial symmetry, principal axis is oroaboral axis. Oroaboral axis. Example, sea anemone. Sea anemone. Sea anemone has an opening called as mouth. That is, shape of the mouth is oval shaped mouth. So this oval shaped mouth, through the oval shaped mouth, we cut through two axes. One is oroaboral long axis, other one is oroaboral short axis. So it has two radial symmetry. So this name biradial symmetry. Example, sea anemones. And third one is other type of radial symmetry is pentamerous radial symmetry. In the case of biradial symmetry, number of planes 2, and number of principal axis 1. Coming to pentamerous radial symmetry, in pentamerous radial symmetry, adult echinodermates exhibit pentamerous radial symmetry. What are the principal axis? Oroaboral axis. Number of planes in pentamerous radial symmetry 5. Number of principal axis 1. That means we cut through the oroaboral axis. It gives two equal parts. This is one plane and this one is another plane. This is third plane, fourth and fifth. So number of planes in pentamerous radial symmetry 5 planes. Number of principal axis 1, that is oroaboral axis. Biradial and pentamerous radial symmetries are a type of radial symmetry. Biradial symmetry is exhibited by sea anemones, belongs to the class Anthozoa. Radial symmetry is exhibited by Cnidarians. In Cnidarians, there are three classes: Hydrozoa and Scyphozoa. Hydrozoans and Scyphozoans exhibit radial symmetry. Third one is Anthozoan. Anthozoan exhibit biradial symmetry. And pentamerous radial symmetry is exhibited by echinodermates. Example, echinodermata, adult echinodermata, starfish. Coming to last one, that is bilateral symmetry. In bilateral symmetry, principal axis is oroaboral axis. Principal axis is antero-posterior axis. Antero-posterior axis. It has two number of planes in bilateral symmetry. Planes in bilateral symmetry. This is bilateral symmetrical triploblastic animal. It exhibits what type of symmetry? Bilateral symmetry. In bilateral symmetry, what are the principal axis? Antero-posterior axis. Number of planes in antero-posterior axis 1 plane. Number of principal axis also 1, that is antero-posterior axis. These bilateral symmetrical animals can be cut into, it gives left and right parts when we cut through the median sagittal axis. What is median sagittal axis? Mid dorso and mid ventral axis. Mid dorso and mid ventral axis is called median sagittal axis. When we cut through the median sagittal axis, it gives left and right parts. when we cut through the longitudinal planar axis, it gives dorsal and ventral parts. So bilateral symmetrical animals, example for bilateral symmetrical animals, all the triploblastic animals exhibit bilateral symmetry except adult gastropodons and adult echinodermates. Bilateral symmetry is the most advanced symmetry. Why it is called as most advanced symmetry? These animals exhibit cephalization. What is cephalization? Process of formation of head or concentration of the organs at the anterior end of the body is called cephalization. Due to cephalization, these animals are advanced animals, or this symmetry is advanced symmetry than remaining symmetries. Example, triploblastic animals. That is about symmetry. Then coming to coelom. What is coelom? The space between body wall and alimentary canal is called coelom. Coelom, the body cavity, the space between body wall and alimentary canal is called coelom. There are three types of coeloms. What are the three types of coeloms? Acoelom, pseudocoelom, and schizocoelom. Acoelom, acoelomates or acoelom. Second one is pseudocoelom, and third one is eucoelom. What are the three types of coeloms? Acoelom, pseudocoelom, and eucoelom. What is coelom? The space between body wall and alimentary canal is called coelom. In the case of acoelomate animals, the space between body wall and alimentary canal, body wall or ectoderm, alimentary canal or endoderm, this is filled with the mesenchymal tissue or parenchymal tissue. That means there is no space between ectoderm and endoderm or body wall and alimentary canal. This type of coelom is called acoelom. Acoelomate animals, example, phylum Platyhelminthes. Phylum Platyhelminthes exhibit what type of coelom? Acoelom. Why it is called as acoelom? The space between body wall and alimentary canal which is filled with mesenchyme or parenchymal tissue. And coming to pseudocoelom. In pseudocoelomate animals, the space between ectoderm and endoderm or body wall and alimentary canal which is filled with mesodermal pouches. These are the mesodermal pouches. Mesodermal pouches. This is ectoderm and this one is endoderm. Ectoderm, endoderm. These are the mesodermal pouches. The space between body wall and alimentary canal which is filled with mesodermal or which contain mesodermal pouches, that type of coelom is called pseudocoelom. That means in case of pseudocoelom, in embryonic stage, this is the body wall and this one is alimentary canal, ectoderm and endoderm. This is mesoderm. This mesoderm attaches to only ectoderm, does not attaches to endoderm. This is ectoderm. This one is mesoderm. This is endoderm. This mesoderm attaches to only ectoderm, does not attaches to endoderm. This space is called pseudocoelom. In embryonic stage, this is blastocele. This blastocele in adult stage becomes pseudocoelom. That means mesoderm attaches to only ectoderm, does not attaches to endoderm. Pseudocoelom is filled with pseudocoelomic fluid. It acts as a hydrostatic skeleton. It supplies digested food material to the different parts of the body. That means which compensate the absence of circulatory system. Example, pseudocoelomates. Example, Eschhelminthes. Eschhelminthes or nematodes. Nematoda or Eschhelminthes. These Eschhelminthes or nematodes are tube within tube animals. Tube within tube animals. Tube within tube animal. First tube within tube animals. Nematodes are Eschhelminthes. What type of coelom in Eschhelminthes are nematodes? Pseudocoelom. Then coming to cystocoelom. In cystocoelom, the space between body wall and alimentary canal. This is the ectoderm. This is ectoderm. And inner layer is endoderm. This is endoderm or alimentary canal. Body wall or ectoderm. Between these two layers, mesoderm. This is the mesoderm. There are two types of mesodermal layers. The mesodermal layer attaches to ectoderm. That is called visceral mesoderm. Ectoderm is called parietal mesoderm or somatic mesoderm. This is visceral or splanchnic mesoderm. Between these two layers, a space is present. This is eucoelom. Outer layer is ectoderm. This is ectoderm. Inner layer is endoderm. This is endoderm or alimentary canal. Endoderm. Ectoderm and endoderm. What are the two mesodermal layers? Somatic mesoderm or parietal mesoderm? Visceral mesoderm or splanchnic mesoderm? This is eucoelom. Eucoelom is again divided into two types based on the formation: cystocoelom and enterocoelom. Cystocoelom and enterocoelom. The cystocoelom derived from the splitting of mesoderm. Cystocoelom is derived from the splitting of mesoderm. Example, Annelida and Arthropoda. Annelida arthropoda and mollusca. Enterocoelom. In enterocoelom, coelom is derived from the archenteron or mesodermal pouches of the archenteron. Example, phylum Echinodermata, hemichordata and chordata. Echinodermata, hemichordata and chordata. What are the two types of eucoelomates? Cystocoelom and enterocoelom. Coelom derived from the splitting of mesoderm, cystocoelom. Coelom derived from the pouches of the archenteron, enterocoelom. Cystocoelom is exhibited by the phyla Annelida, Arthropoda, mollusca. In Arthropoda, mollusca, cystocoelom is also called as hemocele. Why it is called as hemocele? Coelom is filled with blood or hemolymph. In echinodermates, semichordates and chordates. Coelom derived from the pouches of the archenteron, the type of coelom is called introcoelom. That is about symmetry under coelom.